So we're continuing on in Chapter 3, and all of Chapter 3 deals with quadratic functions. And we've already looked at how to solve quadratic equations using methods like graphing. We've solved by factoring. We've solved by completing the square. And we also have another method at our disposal, which you're probably already familiar with. It's the quadratic formula. We've actually already been using the quadratic formula a little bit prior to this lesson. So some of today, we're just going to briefly touch on the quadratic formula, but a big part of today is that second objective, where we're going to talk about this idea of the discriminant. How do we find it? And more importantly, what does it mean to us when it comes to graphing? So once again, you already have this, I'm sure, memorized, but I just went and put it in your notes. Let me jump to the next slide, which involves how to calculate the discriminant. And in green, this is how you find, this is the formula, if you will, for finding the discriminant. And if you notice, it's just the part, if you take the part underneath the radical of the quadratic formula, you've got the discriminant. It's not the radical. Do not include the radical when you're calculating the discriminant. Just take the part that's underneath the radical. And when we calculate this, that number that comes out is called the discriminant. Now let's talk about when the discriminant is a certain number, what does that mean as far as the types and number of solutions that we would come up with if we solve the equation? So let's just start with some scenarios like when the discriminant is positive, and then I'm going to get a little more specific. Not only is it positive, but it has a perfect square root. Like maybe we plug in the numbers b squared minus 4ac and it comes up 49. Well, that tells us that when we do go ahead and solve the equation, find the two solutions, there are going to be two rational number roots. Now, what's that mean as far as our graph is concerned? I want you to be able to interpret it another way, because in graphing terms, what that means is we're going to be crossing the x-axis at two real number, rational number points. Like, for example, I'll just throw you an example here. We would be crossing at -2 and +3, for example. Two rational roots means that we have two x-intercepts. Just draw you a rough sketch of some parabola here. And where we cross the x-axis, in other words, will not be decimals or fractions. They're just regular, nice, clean numbers. When the discriminant is positive and the number has a perfect square root. Okay, well, let's move on to still positive, but what if it's not a perfect square root? Still positive, but the number that comes out as the discriminant is, maybe it's the number 37. Well, in this case, we're going to have two irrational roots. And what that means, interpreting our graph, we're still going to cross the x-axis in two different places, but those two places might be someplace like -1 2/3, and I'm just going to throw out some random numbers, 2 7/8. Still two x-intercepts, but they're not nice, clean integers. Or in other words, they will be some decimal form of x-intercept. So when you answer your questions for homework, and we'll do some examples, your primary goal in answering the questions is this. What is the type and number of roots? And you could throw the word real in there. We're assuming that all of these are real numbers, so that's not a problem. But I want you to have an understanding of what does that mean as far as the graph is concerned as well, even though you don't really have to include the fact that there are two x-intercepts. I do want you to make that connection for future reference. All right, so far we've identified a discriminant as positive that has perfect square root, positive not perfect square. The other situation that could happen is the discriminant is 0. What does that mean for the type and number of roots? When the discriminant is 0, we're going to have one real number root and what that means as far as the graph is concerned is we're actually going to see the vertex. So let me just do a sample here. This means that we're going to have one x-intercept, and in order to touch the x-axis only one time with a parabola, that means it's going to have to be the vertex sitting on the x-axis. Okay, so far so good. And the only other possibility for a discriminant is that it's negative. Board is not cooperating today. If the discriminant is negative, then that means we're going to have two complex number roots. In other words, we're going to have the number I involved in our two answers. And what that means as far as the graph is concerned is we're never going to cross the x-axis. So if your discriminant is negative, that means that you're going to have a parabola that does something like this. Or this. There's obviously several different options, but a parabola that never crosses x. There are no x-intercepts. Okay, so those are your four possibilities, and those are the types of answers that you're going to be giving when you get to problems like this. So let's just do a couple. So hopefully you got your calculator handy. So these are obviously multi-part. There's 6 problems like this at the beginning of your lesson. The first thing we'll do is find the value of the discriminant. So once again, the formula for finding the discriminant is b squared minus 4ac. What you should do first is arrange the terms, arrange the equation so that it's in standard form. So the first thing I'm going to do is make this look like negative 8x squared plus 4x plus 5 equals 0. Now if you made it so that it's positive 8x squared, that's okay, no problem. This is our standard form. Now we're ready to plug into our discriminant formula, so it'll be b squared. 4 squared is 16, minus 4 times a is negative 8, times c is 5. All right, so let's plug into our calculator. 16 minus negative 32 times 5 negative 160. So the value, the answer for part A, the value of the discriminant is 176. So that's answer part A. Okay, based on that number, the answer to part B we just looked at, since 176, does that have a perfect square root? Nope. So that tells us that we're going to have, based on our little table that we made over here, we're going to have two real irrational roots, or we'll just say two irrational roots. Okay, and I'll give you a few minutes, or probably, hopefully less than a minute. Go ahead and solve part C. Really want you to go ahead and solve the equation using the quadratic formula. So obviously you don't have to, you've already got the number that goes underneath the radical. So we'll just set it up for you and I'll let you finish it. So the opposite of B, plus minus, and we know it's going to be the square root of 176. Solving for x, and all of this is going to go over 2 times a, and a is negative 8. Now notice, and I gave you a little hint here, your book doesn't say this, but whenever it says to find exact solutions, you're going to leave your answer in simplified radical, simplified fraction, no decimals, just simplify the radical and the fraction and leave it in fraction form. So I'll give you just a second to see what you come up with there. Okay, to simplify this radical, we can think of the square root of 176 as two radical factors, one of which has a perfect square root, the other one does not. So the square root of 16 times the square root of 11 equals the square root of 176. And all of this is going to go over negative 16. Obviously the square root of 16 is 4, so I'm just going to erase the square root of 16 and put 4 in its place. And now I can simplify the fraction. Because the numbers that are not under the radical can all be divided by 4. So let's go ahead, I'll just come up here and we'll divide by 4 into each of these numbers. Negative 1 plus minus, that's going to be 1 times the square root of 11. Over negative 4. And the only thing I would do here is when you have negative divided by negative, that's really what? Positive. So to clean this up a little bit, you would say 1 plus or minus root 11 over 4. Okay, any questions on example 1? All right, let's try this one. Go ahead and find the discriminant, b squared minus 4ac. I guess we need to clean this up a little bit first. Let's put it in standard form. So I'm just going to add 4x to both sides, and then I'm going to subtract 8. The discriminant, b squared would be 16 minus 4 times a times c. So negative 24 times negative 3, that's 72. And it looks like our discriminant, the value of the discriminant is negative 56. Since the discriminant is negative, part B, if the discriminant's negative, that means I'm going to have two complex roots. Meaning the number I is going to be involved. And so once again, let's state our answer in reduced fraction, reduced radical. See if you can get the solution using the quadratic formula. for part C. Okay, so hopefully you've had a chance to simplify, and your answers, since it's plus minus, again, there's really two answers. You have 2 plus minus I root 14 over 6. So you got that right. 1, 2, 3, 4, 5. Good. Any questions? Yeah.
So when you are simplifying, you don't have to put a negative in front of like I, because it's positive there.
You're saying I is
When you're simplifying, like
the square root of negative 56?
no, like right here, it's like these two cancel out, but this one stays the same.
Yeah, that's a great question. In order to reduce, you have to be able to divide evenly into all three coefficients. And since technically I has a coefficient of 1, and so that's as far as we can reduce. If there had been a 2, if it had been 2I, then we could have reduced further. Just divide all numbers by 2.
It's like that one stays the same, but the other two don't. Is it just because it's plus or minus?
Well, remember, I don't know if this is your question. If I factor out the square root of negative 56, I use the square root of negative 1 times the square root of 4 times the square root of 14. And the square root of negative 1 is literally I.
I was just confused. If it doesn't cancel out. Like in the question above, it was.
So we touched on your answers. I should go ahead and put rational here. It is real, but I don't know why I didn't include rational. You'll have one rational number root. Okay, so I thought I would we're not going to do this whole problem. This is one of the problems that you'll do on your homework. I just thought I'd set it up and make sure you understand what to do. This is an actual quadratic function. The context is the number of people. Since smoking has declined in the U.S., that means the number of deaths by lung cancer has decreased. And just kind of talk you through the 3 steps here that you're going to do. Calculate the number of deaths per 100,000 people for 2017. And I just wanted to point out that X in this represents the number of years after 2000. So part A is pretty simple. You're just going to let X be 17. Grab your calculator and you can crank it out. Letter B is pretty straightforward, I think. Use the quadratic formula to find X if you let Y be 50. So plug 50 in. Obviously, you're going to need to set it equal to 0. Remember, we use the quadratic formula to solve for X. We let the standard form equation equal 0. So let Y be 50, and then change it into an equation equal to 0, and then solve. Okay, is that pretty straightforward? And then letter C, according to the quadratic function, talking about this, here's our quadratic function. When will the death rate be 0 per 100,000? So basically, you're letting Y be 0 and solving. And obviously, you're going to get a negative answer, which is not going to make any sense in this context. We can't have a negative year, so you're only going to take the positive answer. And since it is a year, just go ahead and round to the nearest year. And then I'll let you see if that's a reasonable. This book is, well, it's fairly new, but well, I'll let you see what you get for letter C. What year would the death rate actually go all the way down to 0? And is that a reasonable prediction to think that there'll be 0 deaths for lung cancer at that time. And I'll see what you come up with as far as a reason. Okay, that's it. Pretty short assignment relative to the others. I'll let you go ahead and get started on it, and maybe we'll put it, or I'll give you some answers in just a minute, see how you're doing.